According to the National Electrical Code, the correct wiring method for an air conditioner, heat strip, or blower motor unit with two breakers involves running separate wires from the electrical panel to each breaker on the unit itself. Specifically, use number 6 American wire gauge wire from a 2-pole 60-amp breaker in the panel to the 2-pole 60-amp breaker on the unit. Similarly, run number 10 American wire gauge wire from a 2-pole 30-amp breaker in the panel to the 2-pole 30-amp breaker on the unit. There are several reasons why this is the preferred and legal method. Firstly, overcurrent protection. Using the correct wire gauge ensures that each circuit is protected against overloads and short circuits. Secondly, code compliance. Running a number 6 wire to the 60-amp breaker and a number 10 wire to the 30-amp breaker complies with National Electrical Code requirements for branch circuit sizing. Thirdly, safety. Improper wiring can create overheating, fire hazards, and damage to the unit. Tapping off the 60-amp breaker with number 10 wire to the 30-amp breaker is an illegal tap for several reasons. It violates the National Electrical Code rule that prohibits taps within 10 feet of a panel board. It overloads the 30-amp breaker and wire with more current than they are rated for. The only legal way to wire an air conditioner heat strip or blower motor unit with two breakers is to run separate wires from the panel to each breaker on the unit. This ensures overcurrent protection for both circuits in compliance with code requirements. To delve deeper into the specifics of overcurrent protection, it is crucial to understand its role in safeguarding electrical circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity when the current exceeds the safe operating limits of the wiring and equipment. In the context of an air conditioning unit with two breakers, the 60-amp breaker protects the larger components, such as the compressor motor, while the 30-amp breaker safeguards smaller components like the blower motor and heating elements. Using the appropriate wire gauge for each circuit ensures that the overcurrent protection device can effectively trip and prevent damage in the event of a fault. The National Electrical Code plays a vital role in ensuring electrical safety and standardization across the country. It provides comprehensive guidelines for the installation and wiring of electrical systems, including the sizing of branch circuits, the selection of overcurrent protection devices, and the proper methods for connecting electrical equipment. Compliance with the National Electrical Code is not only a legal requirement in most jurisdictions but also a critical step in preventing electrical hazards and ensuring the safe operation of electrical systems. By adhering to the National Electrical Code's requirements for branch circuit sizing, electricians can ensure that the wiring is adequately protected against overloads and short circuits, minimizing the risk of fires, electrical shocks, and equipment damage. The importance of electrical safety cannot be overstated, especially when dealing with high-power appliances like air conditioning units. Improper wiring can create a multitude of hazards, including overheating of conductors, insulation breakdown, and the potential for electrical fires. In addition to the risk of property damage, faulty wiring can also pose a serious threat to human safety, as it can lead to electrical shocks and electrocution. Therefore, it is essential to prioritize electrical safety in all aspects of electrical work, from selecting the appropriate wiring methods to ensuring proper grounding and bonding. Tapping off the 60-amp breaker with number 10 wire to the 30-amp breaker is an illegal and dangerous practice that should be avoided at all costs. This wiring configuration violates several National Electrical Code rules and creates a significant risk of overcurrent and fire. The number 10 wire is not rated to carry the full 60 amps of current that the breaker is capable of supplying, which means that it can easily overheat and melt, potentially causing a fire. Additionally, tapping off the 60-amp breaker bypasses the overcurrent protection provided by the 30-amp breaker, leaving the smaller components of the air conditioning unit vulnerable to damage in the event of a fault. The National Electrical Code specifically prohibits taps within 10 feet of a panel board to prevent the concentration of current at a single point and to ensure that each circuit is properly protected by its own overcurrent protection device. Tapping off a larger breaker with a smaller wire also violates the National Electrical Code's requirements for branch circuit sizing, which mandate that the wire gauge be appropriately matched to the ampacity of the overcurrent protection device. In summary, the only legal and safe way to wire an air conditioner, heat strip, or blow motor unit with two breakers is to run separate wires from the panel to each breaker on the unit. This ensures overcurrent protection for both circuits, compliance with code requirements, and the prevention of electrical hazards. When working with electrical systems, it is always best to consult with a qualified electrician to ensure that the work is performed safely and in accordance with all applicable codes and regulations. It is essential to consider ambient temperature when determining the correct wire gauge for electrical installations. The ampacity of a conductor, which is the maximum amount of current it can carry safely, is affected by the temperature of its surroundings. High ambient temperatures can reduce the ampacity of a conductor, as the heat generated by the current flow can cause the insulation to degrade and potentially lead to a fire. The National Electrical Code provides tables and guidelines for adjusting conductor ampacity based on ambient temperature. These tables specify the dating factors that should be applied to the conductor's ampacity rating for different temperature ranges. For example, if a conductor is installed in an area with a high ambient temperature, its ampacity may need to be reduced by a certain percentage to ensure that it does not overheat. Another factor to consider when selecting wire gauge is the length of the circuit. The longer the circuit, the greater the voltage drop that will occur due to the resistance of the wire. Voltage drop can cause equipment to operate inefficiently or even fail to start, so it is important to minimize voltage drop by using an appropriately sized wire. The National Electrical Code provides guidelines for calculating voltage drop and recommends that the voltage drop in branch circuits should not exceed 3%. To minimize voltage drop, it may be necessary to use a larger wire gauge than would otherwise be required based on the ampacity of the circuit. In addition to ambient temperature and circuit length, the type of insulation used in the wire can also affect its ampacity. Different types of insulation have different temperature ratings, which determine the maximum temperature at which the wire can safely operate. The National Electrical Code specifies the allowable insulation types for different applications and provides tables of conductor ampacities based on insulation type. For example, some types of insulation are suitable for use in dry locations only, while others are suitable for use in wet or damp locations. It is important to select the appropriate insulation type for the environment in which the wire will be installed to ensure its long-term reliability and safety. Grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to trip the overcurrent protection device and prevent electrical shock. Bonding connects all metal parts of an electrical system together to create a common ground potential, which reduces the risk of electrical shock if a fault occurs. The National Electrical Code provides detailed requirements for grounding and bonding, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the bonding of metal enclosures and equipment. Proper grounding and bonding are critical for protecting people and property from electrical hazards. Electrical panels should be properly labeled to clearly identify the circuits and devices that they serve. This helps to ensure that electricians and other qualified personnel can quickly and easily locate the correct circuit when performing maintenance or troubleshooting. The National Electrical Code requires that electrical panels be labeled with a directory that identifies the purpose of each circuit breaker or fuse. The directory should be accurate and up to date, and it should be written in a clear and legible manner. Proper labeling of electrical panels is essential for safety and efficiency. Regular inspection and maintenance of electrical systems are essential for preventing electrical hazards and ensuring the reliable operation of equipment. Electrical systems should be inspected periodically by a qualified electrician to identify any potential problems, such as loose connections, damaged wiring, or overloaded circuits. Maintenance tasks such as tightening connections, replacing worn components, and cleaning electrical panels should be performed on a regular basis to prevent breakdowns and extend the life of the electrical system. Regular inspection and maintenance can help to prevent electrical fires, electrical shocks, and equipment damage. When working with electrical systems, it is important to use the correct tools and equipment. This includes insulated screwdrivers, pliers, and wire strippers, as well as voltage testers and multimeters. Using the correct tools helps to ensure that the work is performed safely and efficiently. It is also important to wear appropriate personal protective equipment, such as safety glasses and gloves, to protect against electrical shock and other hazards. Always follow the manufacturer's instructions when using electrical tools and equipment. Before starting any electrical work, it is important to de-energize the circuit and verify that it is dead. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Use a voltage tester to confirm that the circuit is de-energized before touching any wires or terminals. It is also important to lock out and tag out the circuit breaker or fuse to prevent it from being accidentally turned back on while you are working on the circuit. De-energizing and verifying the circuit is dead is essential for preventing electrical shock. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. Electrical work can be dangerous, and it is important to have the knowledge and skills to perform the work safely. A qualified electrician will be able to properly assess the situation, identify any potential hazards, and perform the work in accordance with all applicable codes and regulations. Hiring a qualified electrician can help to ensure that the electrical work is done safely and correctly. There are several types of wiring methods commonly used in residential and commercial electrical installations. These include non-metallic sheath cable, also known as Romex, which is typically used for wiring branch circuits in residential buildings. Another common wiring method is electrical metallic tubing, which is a rigid metal conduit that is used to protect wiring in exposed locations. Rigid metal conduit is another type of conduit that is used for heavy-duty applications, such as underground wiring. Flexible metal conduit is a flexible conduit that is used for connecting equipment to electrical boxes. Each wiring method has its own advantages and disadvantages, and the appropriate wiring method should be selected based on the specific application and the requirements of the National Electrical Code. When installing wiring, it is important to follow the National Electrical Code's requirements for conductor fill. Conductor fill refers to the number and size of conductors that are allowed to be installed in a conduit or electrical box. The National Electrical Code provides tables that specify the maximum conductor fill for different types of conduits and boxes. Exceeding the maximum conductor fill can cause the conductors to overheat and potentially lead to a fire. Therefore, it is important to carefully calculate the conductor fill before installing wiring. Electrical boxes are used to protect wiring connections and to provide a safe enclosure for electrical devices, such as switches and receptacles. Electrical boxes come in a variety of sizes and shapes, and the appropriate box should be selected based on the number and size of conductors that will be installed in the box, as well as the type of device that will be mounted in the box. The National Electrical Code provides requirements for the size and type of electrical boxes that should be used in different applications. When installing electrical boxes, it is important to ensure that they are properly supported and secured. Wiring connections should be made using approved connectors and methods. Wire connectors are used to join two or more conductors together in an electrical box. There are several types of wire connectors available, including wire nuts, crimp connectors, and push-in connectors. The National Electrical Code requires that wire connectors be listed and labeled for the specific application in which they are used. When making wiring connections, it is important to ensure that the conductors are properly stripped and that the connectors are securely fastened. Loose or improperly made connections can cause overheating and potentially lead to a fire. The National Electrical Code provides detailed requirements for making wiring connections. Surge protection devices are used to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power line transients. Surge protection devices work by diverting the surge current to ground, which prevents it from damaging sensitive electronic equipment. Surge protection devices are available in a variety of types and sizes, and the appropriate surge protection device should be selected based on the voltage and current rating of the equipment that it is protecting. The National Electrical Code provides requirements for the installation of surge protection devices. Arc fault circuit interrupters are circuit breakers that are designed to detect arc faults, which are a common cause of electrical fires. Arc faults occur when electricity jumps from one conductor to another, creating a high-temperature arc. Arc fault circuit interrupters work by monitoring the current flow in the circuit and detecting the characteristics of an arc fault. When an arc fault is detected, the arc fault circuit interrupter trips the circuit breaker, which interrupts the flow of electricity and prevents the fire from starting. The National Electrical Code requires the use of arc fault circuit interrupters in certain locations, such as bedrooms and living rooms. Ground fault circuit interrupters are circuit breakers that are designed to protect people from electrical shock. Ground fault circuit interrupters work by monitoring the current flow in the circuit and detecting any imbalance between the hot and neutral conductors. An imbalance indicates that some of the current is leaking to ground, which could pose a shock hazard. When a ground fault is detected, the ground fault circuit interrupter trips the circuit breaker, which interrupts the flow of electricity and prevents the shock from occurring. The National Electrical Code requires the use of ground fault circuit interrupters in certain locations, such as bathrooms and kitchens. Understanding the proper wiring methods, safety precautions, and code requirements for electrical installations is essential for preventing electrical hazards and ensuring the safe operation of electrical systems. Always consult with a qualified electrician if you have any questions or concerns about electrical work. Remember to always prioritize safety when working with electricity and to follow all applicable codes and regulations.